Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're back here to work on this little Cary, something preamp. I'll put it up here what it was supposed to be a clone of. But viewer sent me this, wanted me to look at it. I gave him an estimate of a couple $100 to fix it. I'm not sure if he's gonna, want to do that or not, but I'm gonna go ahead and fix it because he initially said that, hey, if you can't fix it easily, I can't get the folks that I bought it from on AliExpress or wherever he got it to do anything, and it does me no good. I think it came with tubes, and he kept the tubes that were in it, and he's like, yeah, if we can't figure out something, then you can just have it. So I'm going to fix this thing. If at the end of it he says, hey, I'm willing to, now that it's all working again, I'm willing to give you a couple $100 with no warranty for fixing it, then I'll ship it back to him. But we'll do some little testing and reviews on this thing and let y'all know what I think of it. But right now it's dead. So I think I showed you in the first video this little transformer, little potted thing that was, actually here's what it is, because I kind of popped the cover off of it to kind of see what it was. But this thing's got an open winding in it. And it wasn't cracked like this. I was just kind of trying to peel that up to see what it looked like inside. And it's just an EI core transformer that's in some epoxy. And then it was in a little plastic cover. But anyway, this thing was dead. And I didn't have much luck looking on Mauser trying to find something that would fit with the same pins and everything. Somebody sent me a link that, hey, here's one that looks similar to it on AliExpress for $5. I'm like, I'm not putting another cheap China garbage transformer in here. And I do want to open this thing up enough. Somebody was saying a lot of these have aluminum windings in it, and I'm curious if this one does. Well, later in this series, I'll kind of show you what that's all about. Anyway, so I ordered a little Triode Electronics EI transformer that I'm going to bolt here in the back. That small enough, it's like 1.5 by 1.5 by 2.5, and there's a spot right here in the back of the chassis where it'll fit. And we're just going to run the wires up here to the board, and then I bought some 105C rated capacitors, some Rubicons to replace these two caps with because I don't trust them, and they're right next to this heat sink. And then I also got it came with a 7812 series 12 volt regulator, and I went with a Texas Instruments LDO regulator because I know they don't get as hot. And they also don't need as much headroom. You can get by with 13 volts, I think, driving them. And I would rather have that headroom than be pushing up against what this can handle. And so it's got a bridge rectifier back here after the 12 volt transformer. And also this has 120 volt windings instead of 110. So it'll actually be 12 volts, which I think is going to be helpful. And then I did do some reverse engineering because when I originally kind of powered this thing up with a wall wart to see if any of this would even come back to life, and it did, but this little relay wasn't clicking. And before I jumpered a wall wart into this thing, I pulled the 12 volt regulator out because I didn't want to be like back feeding it with the wall wart voltage. I didn't know what that might do something weird, so I desoldered it, and this little relay wasn't clicking like I thought it should be. And doing some reverse engineering, looking at the winding, this relay gets its DC voltage before the regulator, and with the regulator out of the circuit, this wasn't going to operate. So I'm hopeful that when I wire the transformer back up into the circuit board and have 12 volts here, instead of like back feeding 12 volts DC there, that this relay is going to turn on when I hit the on button here, and that everything's going to work right. And I'm pretty sure it's going to, but Till you put it in, you don't know. So let's get this transformer put in, let's get this board put in, and let's get these test voltage things run and see if this thing's going to come back to life. Okay, so let's go over what I did to get this preamp back in action. As I pointed out earlier, I diagnosed that this PC mount transformer that had no markings on it, that was just a totally generic transformer, died. And when I opened it up, it was copper coated aluminum wire or copper plated wire. So it wasn't a copper wire transformer, and it had a very just cheap looking regulator IC in this position, and it looked like it had gotten pretty hot, and I'm not sure if possibly this shorted out and took out some other parts or what happened. I decided to repopulate the board, and so I got a new bridge rectifier, I got a new regulator, and I went with a LDO regulator because they normally run a little cooler because they're more efficient. And I bought this external mount triode, I believe was the manufacturer, I'll put the part number up above, of the replacement transformer. I did some searching. I'm sure somebody that was more in tune with doing this than me would have been able to find this replacement transformer in a high quality. I wasn't interested in buying another made in China cheap transformer and have it die again in the future. The way this amp is designed, this board stays powered up 24/7, and it supplies the 12 volts that goes up to the front end board, which then activates all the electronics and turns on, but this never turns off. And even in the instructions that say if you're not going to be using the amp for a while, turn it off on the switch in the back, and I'm sure it's to keep this board from overheating, or this transformer from overheating. And so that's kind of a weird thing that you would have to turn this off. So I wanted to come up with a more heavy duty solution, since this and this are constantly, again, 24/7 running. And so what I did was I directly wired this transformer to the switch on the back of the amp. I mean, you could have run it over here to the board, I guess, but given it was right next to here, and obviously I drilled a couple of holes to mount this in the back, and then I twisted these leads and ran the output of this transformer up here to these terminals on this board that were originally where the 12 volts fed in. Placed these two caps with some 105C high grade Rubicon caps. Again, put a LDO regulator. Replaced this with a new bridge rectifier just to have a known good part. These little caps, I just left them alone, as well as this diode that goes across the coil on this relay to keep it from backfeeding voltage into the circuit when the point's open. It's got a little LED here, and I left these resistors alone after checking them and making sure they're okay. That's all the parts on the board. So you just need two caps, a bridge rectifier, and an LDO regulator, plus this transformer. And it seems to work great now. So when I hook this up, oh, and the other thing I wanted to mention was, originally this relay wasn't working correctly, but I determined that the coil on this relay picks up its power before the LDO regulator. And so when I had removed this and it backfed the circuit with a wall wart, there was no power going to this relay. So now there is. And now when I turn this on, see the LED lights up, and we have 12 volts on the output of this regulator, or it's 11.99, so we've got the correct voltage going up to the front of the amp. And now when I click the button on the front, it activates this LED, which shows that it's turned on this relay, which sends power up here to that transformer, and then you can see the LEDs on this board are now lit up, that it's powered up, the tubes and this board, and then the delay clicks off, and now we have all these, get this whole bank of relays in the back here that are controlled by this relay attenuator. It's working, the input switching is working, and let me show you what the board in the front of this thing looks like. And that's the board that's in the front of the amp that controls all the volume and switching and all that stuff. Obviously that's super complicated logic circuit electronics that I'm glad all work, because that's not something I would want to get into trying to figure out. So yeah, that's basically what we did to bring this thing back to life. And I haven't listened to it yet. I've been told that this preamp does sound really good, and it's supposed to be a copy of a Cary SLP90. That's what it says right here on the board. And it's got some Audiophile caps. Gotta laugh at the name of them. I mean, at some point, if this thing sounds really good, I may come in and put some really high quality, like some Mundorf caps in here, and put some nicer resistors and just repopulate this board with some really high quality parts, and come in here and, you know, revisit this whole section here. And I'm not sure I really like how they have these caps here tucked in behind that heatsink. That doesn't make a lot of sense, but then you got the hot tube right there. I mean, ideally you'd have those caps mounted on the underside of the board, but then the tubes wouldn't fit inside the chassis. Yeah, that just depends on how much I like this thing and how much I trust that circuit board in the front. But having a relay based attenuator is kind of a neat thing, and yeah, if this thing turns out to be reliable now, I may do some further upgrades in the future. But again, I need to look at see if these caps back here are like 85C rated. I may go ahead and replace those with some 105C just to make sure that they can handle the heat of being tucked in right next to these heat sinks. Because, like, look at that one. They've got it right next to the fins on this heat sink, which is kind of crazy. But who knows? It may be one of those things where a small fan would be good too. I'll just have to see how hot these heat sinks get too. They may not get very hot, and that could be why it's okay. So anyway, just wanted to give y'all an update on fixing this power supply that feeds the electronics, how I fixed that, and this thing seems to be working good now. And I think that's a good place to wrap up this video. So there we go. We got this little China clone preamp back up and running. And haven't put it up to a system yet to listen to it, but all the controls work like they should. All the programming and these electronic circuits and everything work. And it just was this little cheap transformer died, which honestly I'm not shocked. And while I'm sitting here looking at it, let me open this thing up and see what kind of material the windings are made out of. So I did pull the insulation off of this transformer, and on first inspection it was like, oh, it does have copper wire. But then when I kind of ran my X-Acto knife across of it, it's copper clad aluminum. And so that's probably why it failed, was using copper clad aluminum wiring instead of copper wiring. And it saves a little bit of money. That's how they hit that price point. And so hopefully that will never be a problem again with this transformer. And that's why I didn't want to go to some importer and bring in another copper clad aluminum wired transformer. So anyway, hope you've enjoyed this little repair video. Now we can run this thing through its paces. Planning on hooking it up to the audio analyzer suite, seeing what kind of distortion profiles and stuff that we get out of it and frequency response, and then do some subjective listening tests and see what I think of this little thing. So the guy I got it from said he really liked the way it sounded, so maybe this is a winner. And could be that all you really need to do with this thing is put a good power transformer in it if you buy one of these. It's not a hard job to do, or, you know, wait till it dies. You may never have a problem with it. But I do feel like having that LDO regulator is going to make less heat, and putting in some better caps in the power supply, even though it's not in the signal path, it's going to help the reliability. So if you're enjoying this content, please subscribe to the channel. Please like the video. Thanks to all you Patreon supporters and people that otherwise support the channel. And until the next video, have a nice day.